introduced the idea of De Morgan's laws. We saw that basically when we are distributing the negation over, and this is the negation of P, and then you have the negation of and. So basically you're, in a sense, distributing the negation over. The negation of and is O, and then you get a negation of Q. The same as or. When we're distributing the negation over or, this is the negation of P, negation of or, and negation of Q. So you have negation of P and negation of Q. As I mentioned before, we can use a table to prove these statements. For example, here you have P and then Q, P and Q, not P and Q, and then not P, not Q, not P, or not Q. Then you can basically build the rest of these statements and check for the second statement as well. So for the second statement, here you have P or Q, then you have the negation of P or Q, and then since we already constructed not P, not Q, this is not P and not Q. So let us take a look at this. P can be true, true, or false. Since we have 4 combinations, we're going to list them all. Q is true or false. But again, we are looking at this in the combination with P. So here you have P and Q. True and true is true. True and false is false. False and true is false. False and false is false. Its negation, the negation of true, is false. The negation of false is true. Now we are looking at the negation of P, which becomes false, false, true, true. And then the negation of Q, here you have false, true, false, true. Very well. Now we just need to combine not P or not Q and see what happens. False or false is always false. False or true is true. True or false is true. True or true is true. So as you remember, now you are just comparing not P and Q with not P or not Q. And as you can see, these two are exactly the same. So the very first law using the truth table is basically visible. Now let us build P or Q, and then not P or Q, and then not P and not Q, and show that they are equivalent as well. P or Q. So since we have the values for P, Q, this is what you're looking at right now. P or Q, true or true, is true. True or false is true. False or true is true. False or false is false. Now its negation, it is false, 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 and then the true. Now we look at not P and not Q. So now you're looking at these two and you're combining them using the connector AND. So here we go. False and false is false. False and true is false. True and false is false. True and true is true. So obviously, these two are equivalent as well. So we basically proved the second statement. Have we used De Morgan's law before? In intermediate algebra, you learned about inequalities. For example, this inequality, if we look at the number line, 0, 1, 2, 3, 4, 5, 6, and the rest of the numbers on the left, on the right, we're just listing some of them. It says, hey, we're looking at all the numbers like x that are bounded between -1 and 4, and 4 is inclusive. So in the interval sense, this is half open, half closed interval, or the set of all x values, suppose x belongs to R, such that x is bounded between -1 and 4 inclusive. So if I want to apply the De Morgan's law, this statement saying that, hey, I'm looking at all of x values such that x is more than -1, and at the same time, x is less than or equals to 4. So this is my P and this is my Q. P and Q. So I'm looking at the negation of P and Q by De Morgan's law. It is not P or not Q. So it becomes not that x is more than -1. It means that x is less than or equals to -1 or, and becomes or, x is more than 4, right? That's the negation of this statement. But on the number line, it's basically like this. Here we go. You have your number line. 3, 4, 5, 6, -1, -2, -3. So basically, we look at the union between these two intervals, right? On the left-hand side, the interval starting from -1 and going down. And on the right-hand side, we use an open circle on 4 and to the right-hand side. But this is the union between -infinity and -1, union 4 to positive infinity, in the sense that we are writing these on interval format, or we're visualizing these using interval notation and the number. So as you can see, and is now converted into or.